Hello, everybody. Can you hear me okay? Is this okay? Good, good. Yeah, thank you for coming. I'm going to talk about it, coincidentally, a topic that's very close to my heart. I want to start with a fact that I learned the other day. And that's a fact that really deeply impressed me. As of 2018, as a humanity, we managed that only 9.2% of humanity, according to UN statistics, live below the absolute poverty line. That comes down from almost 50% when I was born. Yes, I'm old, but not that old. And why is that? That's because we as humanity have been innovating, constantly adapting and driving forwards more and more innovation, more and more new stuff, and we're continuing to do so. Right? When I went to university, we were talking about artificial reality, virtual reality, augmented reality already then, and that was a long time ago. And maybe we're at the point now that will actually happen. The problem with innovation, and we probably should say for most people, we're not innovating, we're just adapting to what happens around us. It means we have to constantly change and work hard to keep this. And as we all know, changing IT systems is extremely hard. We have many, many customers that are struggling with legacy applications, with stuff that's built in the 70s, like big banks usually have it. And I personally have a banking background. There was a lot of that stuff around. I think every major bank still has a mainframe system. One of the systems that we used was called WS80 because it was created in 1980 and hadn't seen much change since then. Just as a little bit of an introduction, I lead our financial services industry solutions team. And before joining MongoDB about 15 months ago, I worked in multiple banks. I worked as well as a department head in IT, as well as a trader on the trading floor, trading FX exotic product. So I have a pretty broad background on this stuff. All the examples I have in my talk will be finance examples. It doesn't mean there's no other examples, but I'm obviously much more comfortable talking examples from my home turf. If you're from another industry, feel free to ask me about examples in other industries that I can give you, or I will relate it to the industry respectively. But pretty much everything is transferable to other use cases. So, as I mentioned, change is inevitable and it's getting faster and faster. The time to market has to be shorter and shorter. And pretty much every system we build is legacy when we take it live. Because we always build for yesterday's requirements. There's nothing around it, right? There's a latency, a lag. And the second fact that we all should be aware of is that writing new components is much, much easier than changing a running system. As I said, I come from a trading background, and I always compared updating a trading system to performing heart surgery at a marathon runner during the race and still trying to win. It's bloody hard. So you don't want to really do this. So what do? We always end up with architectures that look like this. Unfortunately, we can't see the colors here. We end up having data across many, many different systems that we rather would have in one place, that we need to operate on. We end up having multiple different technologies. My own FX trading management system had 3 different database technologies, 4 different messaging systems, 5 different programming languages, and I stopped counting stuff at this point. It was a horrific mess that was built up over 25 years. And many, many different data sources, messaging queues, all of those things. Nothing really quite fit together. It was all kind of like a little awkward. Everything was slightly different. And last but not least, we ended up in an asynchronous infrastructure with loads of messaging topics and queues between stuff, which makes it even harder to operate on. So if we now have this architecture and we have to deal with this, there's a solution that I see with pretty much every customer I talk to. In hindsight, I actually see it in all of the technology solutions I've used in when I was on the trading floor, as well as the stuff we built. And the pattern is the operational data layer or operational data store. I don't know how many of you have used this pattern, are using this pattern, but if you look hard, you probably find it all over. It's pretty ubiquitous. And we have a lot of customers that are very successful with building operational data layers in MongoDB because of our document model and how that's driving stuff. How does it work? Okay, we have our transactional services that are still the heart and the core of our system. But over the last year, we have become really good at using change data capture to flip that data into a secondary data store, our domain object store, operational data layer. And then we have our microservices that can sit on domain objects that we're creating out of the exhaust from our transactional systems. The key thing here is the flow of data always goes from the left to the right. The transactions operate against the transactional services. We're not changing the core infrastructure of processing. We're just taking a copy and replicating the data out. And then the microservices can operate on domain objects very neatly, very fast. This sounds like a bit, I just have one more systems to update. That's the downside of this. But we've seen customers that were forced to implement a new mortgage system during the pandemic, and they had forced to do it. And they said, okay, they adopted this pattern, got the solution out there, took them a little more than 4 weeks, but it was too ambitious. And as soon as they had the data in a domain model, in a document model on the ODL, there was no stopping them with innovation. The thing they implemented, this was a bank, by the way, they implemented a car sharing application where you could borrow somebody else's car backed up by your credit with the bank. So if you would have totaled the car, the bank would have backed it up with the stuff. It's pretty amazing what they could do as soon as they had unleashed the data. How does that fit with a wider transformation story? As I said, we have N+1 systems now. That's not really cool. We ideally want to get rid of this. This is a standard adoption path that we see all over the place. The first layer is I'm getting data out of one system into my operational data store. And that is fairly basic. Often I can do something like mobile apps, mobile payment with this, or any of the other things. The next step is that I start integrating data from multiple systems into a single document. We call this the enriched ODL. Think about, payments processing, you have the payments data from one side, and every time it goes through another system in your rail, you enrich the status and say what it does there. And then you go through many other steps. The parallel write is where you basically write into the ODL at the same time as in the back end, which then means the ODL becomes much lower latency. And then at some point you flip where you actually read your account balances, for example, from the ODL to check if the person has credit available. That's when you shift the system of transaction. And at that point in time, your legacy systems are just downstream feeds. Maybe you're doing securities journaling of your legacy system. You don't want to change your securities journal just because you have a new fancy trading system on the front where you do this stuff. So you can still keep that. But at some point in time, you probably want to retire that and just take it out of the stream completely. The cool thing about this, you deliver value to your business customer every step of the way, right? It's not you have to start from scratch, rebuild everything and do a big bang migration. Every time you peel off a little slice of that onion or that big ball of mud that you have at the bottom of your stack. So there's 3 patterns of operational data layers I've been seeing and recognizing. The first one is the one I just talked about. You're taking the data out of your operational system, make it available to whatever new application service you want to build, and you're allowed to operate on that. This gives you modern APIs, you can speed up development, you can deliver more functionality to your customers. You also increase your responsiveness and resilience. If you have a relational database, normally we used to shut them down on the weekend, re-index stuff, clean up stuff, purge data, whatever we did. But during that time, it wasn't a problem. It's a trading system. Nobody trades on Sunday mornings. It was fine. But 1, that window got smaller and smaller. And 2, that's not good if you're a payment application or a credit card system. Imagine your bank shutting down their credit card system while you're trying to pay for your dinner. I don't think that would be something we would tolerate, nor would the vendors like it. So this is the data access layer pattern, I would call this. The second one is the operations data layer. And this is something that is more internally focused. It's not necessarily something you would give to the end customer, but there's a lot of people that are using this. Whenever you have complex processing workflows where things can go wrong and things can get stuck, people are using this kind of thing. What you're getting, so again, I'm coming back to payments. You could also do this for deliveries, shipping, anything like that. You bring all the data from all the different steps in your process into one place and make it available for your support staff, your customer support people, making it available to them, make it convenient for them to get the holistic view. Often, there's very, very lightweight applications. It's more an informational tool, but we've seen customers do that more and more. And because people have access to better data and don't have to scramble to get the data from many, many different places, you reduce your operational cost. And the last one is the one that really is kind of like the most obvious one. I call it the development data layer. And since you're probably building an ODL anyway, you might as well do that very, very early and use it for your development effort as well. What does it mean? It means that you can actually access the data, make it available to developers in a holistic view very, very early during your development process. You then can iteratively enrich it and make it better and better until it becomes really super powerful. Why is that so important? I think one of the biggest challenges that we all face is scaling teams. Training people, getting people to understand your data model, understand your data structure. If your data model has 60,000 tables, which is what Temenos, one of our partners, have in their core banking system, that's incredible. Imagine how long it takes to learn about these 60,000 tables. I spoke to their head of product management yesterday and about some of the stuff. He said, yeah, there's probably 5 people left in the company who know how this specific thing works. It's pretty scary. I remember that from my own world, that we only had 550 tables, but there were some tables where nobody knew what they were used for anymore. So it's kind of scary. With an ODL, you bring this all together, you aggregate, you enrich it, and I'll show a little bit later how that would work. So apart from the fact that it reduces the training time, it makes developing software easier and hopefully more fun as well. I think it's also a great tool to help you identify and create test data, to really move from this low, slow cycle of development, QA, failure, development, QA, release, rollback, and so on, to a DevOps environment where you can automatically test stuff. You get confidence that you're changing stuff. And you can do that with an operational data layer because you can record the data pre and post and then diff it against your system. I think that's super powerful as well. And I promised you to speak about search for a little bit. My first touch with search was when I built a document management engine based on Lucene, and because I believe search is how humans interact mostly. We are not very precise search engines. We are fuzzy search engines. That's our superpower, right? I can express the same thought in 15 different ways and you will still probably understand it. It's really how humans interact. That's why if you look at the Google website, they termed the verb after it. It's called Googling. It's a synonym for searching, I think. It's pretty amazing how fast search is that. We always think about searching in the application, right? You know, when I now make a payment, I don't have to type in the account number anymore. I type the person's name, it finds the phone number, and then from the phone number it references to the accounts. That's how we pay in Switzerland. I don't know how it works in the US. That's the kind of search capability we are thinking about first and foremost when we think about search. That's what you do with your data access layer. Now I have all my accounts in my data access layer, I can query for them, or my payments or whatever else. When you go to the operations data layer, that becomes even more interesting. because you're searching against your aggregated documents where your transactions, shipments, wherever you are. And really, you don't need a GUI anymore. You create a search bar and you just surface the JSON to your internal people. You can't give that to customers. I'm not recommending that because you don't want to expose all that data. But internally, you can now see, oh, this happens there and this happens there. I wish I would have had that functionality when I was on the trading floor. We booked pretty complex transactions across 10 different systems. Security there, loan there, deposit there, and so on and so forth. Each of these systems used numeric identifiers, between 15 and 25 characters long. And our core system that we stored all the data in had 10 different ID fields. There was a Wall Street Systems ID, there was a Tarzan ID, a Phoenix ID, a TTN, what I don't even know what that stands for, 10 different things. And you had on the search screen, on the query screen, you had 10 different fields. Wall Street ID, Tarzan ID, Phoenix ID, ... When you got an inquiry about one of these transactions, says, oh, your transaction 174327B has broken. You're like, well, how do I know which identifier that is? Which system it was? So what we had to do, don't laugh. First, we learned how long the things roughly are. And we had to take that number sequence, put in the first query field, that's the highest potential, press query. When it failed, we knew it wasn't there. Then we copied it to the next field, queried again. You're laughing, ha ha ha. Literally, we had to do this while somebody's screaming at you. So it wasn't very comfortable. And then you rinse and repeat that. And as we all know, to be sure that we didn't miss it, we had to try all 10 fields. Obviously, you could implement this better by searching and pushing it into the application. Nobody ever bothered to do that. But if you have search, you don't have that problem. You type the first 7 digits of that bloody thing, or any 7 digits on the end, you query, you get 5 candidate traits, you match it with your eyes, you got the deal you want. I wish we would have search. And as you probably all know, search is only available on Atlas at this point in time. The number of conversations I have with customers that are saying, can we have search? We want to have search on-prem for these kind of use cases is pretty amazing. I'll show you some concrete use cases later. When we go into the development cycle and the development data layer, I think that is probably even more exciting because suddenly you can ask your systems questions that are much easier. You don't have to figure out which tables store data about business object 1, 2, 3, 4, 5. You just say, show me all the records where I have 1, 2, 3, 4, 5 in there. And then humans are pretty good at ignoring the first 5 hits on Google. We'll ignore the things that are not fitting. If there's a car number that's 1, 2, 3, 5, 4, and you're looking for financial transactions, you're just going to dismiss it. Key thing here is the consumer is a human. The consumer is highly failure resistant and tolerant in this case. So I don't think if anybody has ever built a system that does processing based on search. We tried that, it was horrible. Well, we're using Elasticsearch, which is a great tool, but not for this kind of use case. So you can now search for test data. You say, for this transaction, what data do I produce across my whole stack? And you can check, oh, it goes there, it goes there, and it goes there. As a developer, you can investigate what's going on, and really that helps you drive stuff. Because we often had the question, this transaction went from this trading app to this back office system. Which steps were in the middle? How do I find out, why did it not go through this system? And then you dig into it and you find out. But querying through that with individual databases is very, very painful, in my experience. So there's 3 different ways I think, simplistically, you can build an ODL. The first one is you just copy the relational schemas you have, assuming you have a relational row-based schema currently. That's kind easy to do, but you end up with a problem that actually has become even more complicated. You start with three databases, let's say it's 500 tables. Now you end up with one database with 1,500 tables. That is not really nice, and it's much harder to reason about and think about. You also have the problem that all your messaging infrastructure probably uses XML or JSON or some other hierarchical data structure that doesn't really fit into your relational schema, so you have to tweak that, store that in there. Common approach is to use club storage, performance problems, can't query into it, can't do much with it. So not a good solution, but fairly common. The next solution is you define a data model and you unify everything into that data model. Anybody tried that? I'm sure you all have tried it. It's called a data warehouse. The problem with that approach is you first have to invest a huge amount of time in figuring out what your data model should look like. It's an upfront investment that you do. Any upfront investment in agile tools is called waste. You shouldn't need to do this. The problem also is it's very, very difficult, I would say impossible, but that's maybe too hard a word, to find the right data structure that would work for every use case you have. So usually, once you've built a data warehouse and you have a change request, it either takes forever to make the change, or you basically build a second data warehouse. I don't know how many of you work in an organization that has more than one data warehouse. We had multiple. Every customer I worked for with a consultant had multiple data warehouses or things that were essentially data warehouses. And we still have the problem that we need to build all this ATL logic, which is hard, and we still can't map the documents. And this is where the document model becomes so important and so powerful. Because instead of having to decide what your data model is up front, or just dumbly cloning your stuff, you can just incrementally enrich your document. The more you learn about your data structures, the more information you can put in the aggregation, the more holistic your view about a data process, a customer, whatever you have is, the more you add. And it's very simple to do, which means you have short time to value. You really get that stuff flowing very, very quickly. Let's talk about a couple of practical examples. This is the standard data access layer model. We have on the left-hand side our operational systems. We don't want to touch them, right? Never touch a running system. It just creates hassle if you don't have to. These systems expose their data through data services with an ODL, backed by an ODL, to our microservice, our mobile app, whatever we want to use it for. And these apps then use transactional microservices that sit on top of the legacy infrastructure to drive new transactions back into this thing. This is kind of like ODL 101. We have insurance customers, we have commodity traders, we have companies in telco. It's everywhere. It's literally everywhere. It's a standard pattern. You could say this is just a cache. It's a little more than a cache because you actually change the data structure as well, and you have resilience to it, so you don't have to warm it or something like that. But it is a caching construct. Here is what one of our partners, Temenos, I don't know how many of you are familiar with Temenos. They're a core banking application provider, one of the largest one of those. And they have recently done a high watermark benchmark with MongoDB and put their whole platform in addition to relational databases on MongoDB. And they have done for years, have used an ODL pattern. They had their core platform called Transact, which has an end-of-day backend monolith and has transactional services on top of it, on top of a database for the backend. And then they replicate with a CQRS pattern into what they call microservices, have a separate database to back that up. And they have now microservices that have accounts and payments and all securities transactions, whatever they are. And that's the read-only ODL part of the system. What does it give them? Here are the numbers they published. So I haven't counted them themselves. That's what they published as of their presentation. They did 150,000 operations per second on a single node or a single replica set of MongoDB with 21 milliseconds of latency for the maximum. And they saved 50% of infrastructure cost and ESG footprint doing that. We have the head of product management for Transact speaking this afternoon, I think at 2:55, about his details and how they did it. I've seen the presentation. I think it's pretty cool. It's pretty amazing. This is the use case that I never realized it's an ODL use case until I joined MongoDB about a year ago. And even then it took me a while. This is the classic risk management use case. And here the use case is you have all kinds of systems that were not built to really give you a stable snapshot, but you need to have a consolidated stable snapshot to operate consistently across your different calculation engine, nodes, balance sheets, whatever you have. And I've seen this pattern deployed in most of the major investment banks, trading houses. Some of them are some of the oldest MongoDB customers, it feels like it. Definitely one of them has the largest single replica set cluster I've come across with 100 terabyte. We didn't have sharding when they built this thing, so that's why it's all in it in one. And they're taking snapshots so that they can keep the world stable while the trading systems, the order management systems keep moving. But because they need a stable view for the end of day processing. And then they need horizontal scalability because they have tens or even hundreds of thousands of calculation nodes doing all the complicated math they need to do to calculate the results that they then need to publish to the regulators. And that needs the horizontal scalability. Pretty common pattern. I can't name them, but you would all recognize the names. Pretty much all of Wall Street uses it. I also said there's a second pattern of use cases. These are the ODLs for operations. This is where internal people use the ODL for customer service in various different ways. One area, fairly common, is a payments ODL. SocGen has one of those. And they are thinking about corporate payments. Corporate payments, payrolls, and stuff like that have relatively high failure ratios. And the problem is if your payroll doesn't work, I think you're going to have a lot of unhappy employers. You have a very short time to recover that. So the better your people that can investigate why somebody didn't get their money are, the better it is. That's why they're using payments ODL. The second one is fairly obvious, is the customer 360. You're a relationship manager, a bank teller, whatever you are. You have a customer standing in front of you and telling you they want to buy a house or take out a small loan or whatever. You need to know what that customer is doing with your bank, right? You need to know how much assets they have. You don't want to troll through 15 different systems to find out if they're actually good for it. So you need an ODL for that. Okay? We're verifying OneDrive here. And then last but not least, post-trade processing. Again, once you've executed a transaction on an exchange or marketplace or whatever, there's loads of settlement stuff that needs to happen. That's very complicated. That's another one. So this is the Payments 360 view. This is, by the way, a slide they created. We just rebranded it and took the name off. You see that they have many, many different payment rails. I don't know if you're familiar with payments, but think about any kind of front-end processing systems here. All of these systems had manual monitoring, sitting in front of screens, people watching log files or status bars or whatever. But the problem was they had so many of those. They had, I think 22 was the number. When the corporate customer called up and said, what happened to my payroll? Why did Joerg not get paid? It took them hours to figure out in which system should that payment have happened, because I live in Switzerland, have a Swiss bank, so a dollar amount settles slightly differently than it would settle for a US account. And then they're running around orchestrating that. They have a customer success operator that actually calls all these product specialists that look at the log files and say, have you seen Joerg's payroll? Have you seen Joerg's payroll? 22 times. Obviously, they use Slack channels and email, but it's still a mess, an operational mess. Unfortunately, there's a 24-hour service level agreement that they never could make. What did they do? They created a payment ODL, put all the data that they got from their incoming systems, all the stuff into that ODL, made it available to a payments portal through their operatives, to their customer service agent, and cut down their cost because they needed less of the people running around. I think I'm still allowed to say like headless chickens. They've finally complied with the European Payments Directive, PSD2. They achieved a 99.99% uptime, way better than their core systems because they had all that information offloaded. And they also have now a full end-to-end management of the payment status. They're super happy about it, it's super fun. They can't use search because they're on-prem, but imagine they wouldn't have had to write anything apart from the search bar if they would have just exposed the JSON to their people and just used search. You can then still buy custom renderers for the data if you like to, but you don't need to. Humans are pretty good at reading JSON. This is another one. This is an operational ODL for post-stage processing from one of the biggest brokers on the planet. They had 25 different exchanges. They built their post-stage trading platform based on MongoDB, Atlas. They're feeding their 35 downstream systems, and they build all kinds of features on top of that thing to actually trace that. They have automated exception management processing. All of these things are added on this ODL. This is where the ODL is moving away from a pure cache. The exception management sits directly on MongoDB and not on the primary systems anymore. They didn't build a separate system. So that's where you're starting this blending. When it goes up the scales, you're starting to see that. With search, it makes it much easier to even deal with situations that you didn't predict when you implemented the system. The failure modes where you're tracing an exception, and by exception I don't mean throw a new exception, something. I mean an exception in your business process. Some account doesn't exist, some security isn't defined, you have missing static data in all these cases. So I talked about the first two things, how we operate with systems. We use systems and we need to run and operate them. What I haven't talked about is how can it help us with building a system. And I think because when you build an ODL, you get that kind of like for free anyway. You can actually always build that first, the developer ODL, because then you have the data available to you. It doesn't have to be production data. You can use data from your environment. That's all fine. It will have still the same structure. What do I mean? How I envision this happening? We did similar stuff ourselves. You have many different tables across all your different source systems. Just for simplicity's sake, I prefixed every table with a system ID. These here are systems 1021 and 878. And then I have the usually rather cryptic mnemonic table names. Now, I can push this all into one collection on MongoDB. No big deal. And flatten it out, so to speak. Now, if I do search on this, and I search for the ID, which is here, the D52 EBB62, just, I use the GUID here, then I can find all the records related to that specific ID. Very unlikely that I hit something wrong, but if I do, I can ignore that. I get immediate view of everything that's related to, in this case, this customer. I don't have to ask somebody or read a documentation and ask, where is the phone number stored? I just find the record by doing a search across my whole holistic collection. What's the next step in my development process? Because development is always a process. Obviously, the next step is I build a little bit of an aggregation pipeline, aggregate all the data into one document, and if I'm smart about it, I also add the data sources at the end so I can reconstruct where the stuff actually came from. I can just take a full copy of the thing. I just here put 2 account numbers here. And then as a last step, I have a ready-made JSON that I can expose through our data API or GraphSQL API directly to my mobile app to see my account information and other things. And obviously then I'll find out, but I'm missing the street. Now I'm going back, do another search, look if I can find another identifier for the same person, maybe search for that, and I iteratively build up my data model while I'm building my application and learning about my requirement and my data structure iteratively. Just at the end, I wanted to say one last thing, after the late Steve Jobs, but it's not quite that big yet. Everybody talks about large language models, and you heard probably from Zahir announcing that we're adding vector search to our capabilities. If we think about it, and I thought about what can we do with large language model in the context of ODLs. Obviously, these ODLs need the data they operate. This large language model need the data they operate on. That's why we built vector search. That's one way. But what kind of questions can I ask my large language model? In the data access layer, I can ask, where did I spend too much money? And the thing can figure out that spending too much money on booze is probably not a good thing. On the operational data layer, I can ask, what's happening to this transaction? I can ask, is this transaction actually executed like all its other things? Is there a difference? I can ask these smart questions about it, which I find pretty cool. But the coolest use for me, and I tried that it actually does work to at least as far as I pushed it, is in my ODL, I have all the input and output data of all these processing stages across my bloody system. And by system, I mean my architecture, right? It's a holistic system. I can actually put the input and output and ask ChatGPT to create code that translates it. And often these translations are not that complicated. It does a pretty decent job. That's the thing what I want to explore over the next couple of months and see how far I can push it. Thank you very much. We have a couple minutes for Q&A. Any questions?
Don't be shy, everyone. If you have a thought in your head, say it. Now's the chance. And while you're thinking, maybe this might be something in your head. Joerg, how do you handle all the latency between ODL and the core systems? Maybe that's a question.
So this is the question that I always think back to the head of front office risk management of a major trading firm. And he says, synchronicity is a fiction of our mind. You don't need it usually that much. And when you look at the transactional path that I showed, you use for anything where having late outdated data would be mission critically wrong to your system, you'd go directly to the source of truth. So example, payments, I use that example. To see what account balance I have, you don't go to the ODL. Go to the system and get it validated there. In most use cases, however, that's the last step you're doing, because the probability that it fails, it's just a failure mode you're adding. You have to deal with these kind of things. So it's a trade-off between you have latency, which means it might fail late, or you can't see your account balance on your mobile phone when you don't have reception. Those are the choices you have, or your mainframe is down, the choices you have. So I always advise people who think latency or synchronicity is a fiction to do a simple, please do it as thought experiments. Kick with your foot against the corner. You will perceive, well, at least I do, perceive the impact of your foot visually at the same time as you feel the pain. Physically, the signal needs 3 milliseconds to get from your eyes to your brain and 50 milliseconds to get from your foot to your brain. How does the brain gap the 47 milliseconds? It can deal with asynchronicity. And I think we can deal with that as well, but we need to think about what the impact is on our business process when that latency happens. Can I afford it? The famous examples are ATM machines will give you cash. Not a lot, but a little bit of cash, even if they don't have connection to their mainframe. The banks say, I'd rather give Joerg $10 than having him complain the next morning that the ATM was offline. So it's a risk assessment that you have to make, and often these problems are then practically quite solvable.
I'm an inquisitive person, so I can probably do another one, but yes.
Yeah, so I have a question regarding the ODL. The challenge we're facing right now is how can we aggregate the data to present to the end users with the selected for data from different tables.
Sorry, I didn't understand that. Let me hop down here. Sorry.
Sure. So the question we have right now is how can we aggregate the data from different namespaces, right?
Yes.
Very large data, and how you present into the end client like your demo here. So the question is, number one, performance. So we're always facing this kind of challenge. So does the ODL is fast enough to provide real-time users to query and present?
So the question is, how do you deal with presenting the data you have in the ODL to the end user, and you're having performance problems on your ODL? So performance is always kind of like a mixed bag. You have latency issues or throughput issues. It sounds to me like I have a latency issue, right? So obviously, if the replication, I can't go back that far, the replication from the core system to your ODL takes 24 hours. I hope it's not that slow, right? But 24 hours, that means you can't use that for a payment system, right? It's almost like when I had my first bank account, you got a monthly statement in the mail. I hope nobody else remembers that, but so that's just that the ODL can't do anything about it. The second question is about throughput. How many transactions can your queries, how many mobile people can check their balances on their mobile phone every millisecond or a second? The key thing to do this is you need to build your data model in a way that's scalable, horizontally scalable, not vertically scalable. That's why document databases were built. That's what the guys at Microsoft, who apparently were the first people to build a document database for their web store, they came up with that idea because you have to do your data structure, instead of taking 60,000 tables and map them into 60,000 MongoDB collection or document types, whatever you call it, you do an aggregation and enrichment stage. So that, for example, when you look at a customer like me on my payments account, you would include into my account data the last 20 transactions. Which means I can go with O of 1 performance to retrieve that document, because there's only one document I need to retrieve. So my favorite interview questions for new hires in my development teams was always, what's the performance of a hash table? And why is it relevant for Google? Because if you have a unique identifier, and a hash is a unique identifier, or a subset of that, you can actually access one. So scalability is, if you don't get scalability, it usually is because you have to join data across multiple collections, but you should have done the join in the enrichment when you create the data on the ODL. Does that answer your question?
Any other questions? Things that you're thinking about? I have one more. You talked about the developer ODL.
Yes.
And you talked about how that can help early on in the cycle. Some people think that developing an ODL just for development purposes is a waste of time. What are your thoughts on that?
So there's two things, right? The bottleneck that I did see most of the time wasn't my database. The bottleneck between me and value was always developer performance. So, there's an estimate by McKinsey that says we get 5 to 10 cents on the dollar in financial services for developer productivity. The rest is waste. So even if it would be extra effort to build that ODL for developers, it's probably investment well spent, money well spent. However, when you're building a system that's based on an ODL in production, you're building the ODL anyway, because you're having a development version for the ODL that you're testing against, that you're playing with, that you're operating on, that you're learning about. So let's use it during your development as well. You're not building an extra ODL. You just use the development version of your ODL to help you with your development.
Great, thank you so much. We are out of time. Thank you so much to Joerg and your attention today. If you like the talk, please scan the QR code and rate and give us your feedback, and enjoy lunch.